Hello and welcome to this video. Here we'll be learning about solving some harder problems than previously taught. Alright, so I'm saying some harder binomial expansion problems because they are just 1 or 2 degree maybe harder. They're not impossible. So you'll see one example here I'm showing you. You have the expansion of 3 minus 2x to the power of 7, which you will evaluate with binomial coefficients, but then you do have to multiply with one extra factor as well, which is just one step further away. Alright, so let's start with an easier example here. We've been asked in this first example to find the coefficient of x to the power of 4. So there is no need to actually go ahead and write every term. There's going to be 11 terms there because the power of bracket is 10. So you don't need to write 11 terms. We just need to focus on x to the power of 4 here. The question is asking us for x to the power of 4. So we will have 3 with x raised to the power of 4. Now what's the power of 2 going to be? 10 minus 4 is 6. And the coefficient will be 10 choose 4, which will be the same as 10 choose 6. So all you have to do is say, okay, I will have 10 choose 4 times that by to the power of 6 is 64, and 3 to the power of 4 is 81. So that would be x to the power of 4. The coefficients, remember in the first few lessons I said we've just factorized the x to the power of 4 and you realize the rest. Okay, so final answer should be that number there, 1,088,640. Okay, I hope that was helpful. So the next question, we have to look out for coefficient of x cubed. That means this bracket here, we need to actually figure out the coefficient of x squared because we have one extra x out on the outside, and also x cubed because we need to finally multiply that by the coefficient of x cubed. Alright, so you'll see what I mean if you first figure out these two coefficients. So that means when x is raised to the power of 2, minus 2 needs to be raised to the power of 2. And that means that at the same time 3 is raised to the power of 7 minus 2, which is a 5. And the coefficient there is 7 choose 2. Now for the next term we'll use 7 choose 3 first. 3 will be raised to the power of 4, and when x is raised to the power of 3, that means minus 2 is raised to the power of 3 as well. So we will evaluate this with our calculator first, and then you write it like so. You make a table here and you say I need to actually have a 2 and an x here, and I write them on two different lines because that helps me figure out what I'm looking for. I'm going to multiply this 2 by this term here to the term above it to find out what goes in this box. This box will have a power of 3, x to the power of 3 here. I'm going to write the x power of 3 on that side. And there's no need for me to evaluate this box here because it's 2 times anything here will have x to the power of 2. I'm not going to waste my time evaluating that. But I do need to evaluate multiplying what's above here with this x here, because at the end this x squared times that x, I thought ahead about that and I thought that is going to give me x cubed here. So negative 2 squared is going to be a 4. So I write times 4, 3 to the power of 5, and 7 choose 2. Now I'm just gonna wipe this off now because this is just to show you that what the starting methodology is, and then I'll show you a neater way of writing the same thing, just writing the same thing with my PowerPoint here. So this is just explaining to you that right bracket and left bracket will be multiplied. So in the end, we evaluated these two terms and we putting them in this box here, remember? And I showed you that there is unnecessary. Okay, I wrote x first and then 2. Previously I had 2 first and then x. Doesn't matter. So when you evaluate 7 choose 2 times it by 3 to the power of 5 and then you'll have a 4 here. Okay, so these numbers are what's here to 20,412 and negative 22,000. So what we will do here, notice now we got x cubes here and here. So these are two separate terms, okay, but in the end, this is a plus sign here. In the end, when you're evaluating this expression here, that means you need to add these coefficients with each other to get x to the power cube, right? X cubed will on the end have negative 24,948 as its coefficient. Alright? So this is a harder example. So I've written color coded it here for you. So you can choose to write it this way or if you wish, but the point is use the table for you to not make unnecessary calculations. I've seen these questions come in an exam and you have limited time in an exam. You don't want to waste your time calculating unnecessary coefficients that you will never use and the examiner won't give you mark for. No matter if you get this box right and these other things right, the examiner won't give you mark for that. What's necessary for us is these two coefficients here that we found and added together in the end. Alright, so finally let's look at, well, this is not the final example but the third example. So g of x is this 1 plus kx raised to the power 10. K is a constant and the coefficient of x cubed is given to us. We need to work backwards to figure out the value of k. So what we do here is we say if we have coefficient of x cubed, it means that k is also raised to the power 3 with x, and we have k cubed in our expression here, right? So what would be the coefficient of 1? Actually, 1 doesn't matter, but the coefficient, the binomial coefficient itself, 10 choose 3 does matter, okay? So I know 1 to the power 7 is still 1, but 10 choose 3 is that, would be 10 choose 3 is 120. Alright, so 120 times k cubed is equals to 15 x cubed. I'm gonna put x cubed here because I have x cubed here. So these x cubes cancel each other out, and I'm solving this equation here. Let's say I divide by x cubed, and now I'm gonna have both sides divided by 120. So I'm solving for k. So 15 over 120, I believe, is 1/8. And taking cube root of both sides, you're going to get a half. Actually, yeah, positive half. So that's the answer. That's what the answer should be. And let's check. Yes, it is a half. Okay, so let's look at the next example. In this example, we've been told to first write down the first three terms of in ascending power of x. The word ascending means like an airplane taking off. Ascending means go up. So we start with x power naught and then x power 1, x power 2, and we do need to write three terms, don't we? First three terms. So 1, 2, 3, that's enough. So when x is raised to the power 0, 1 is raised to the power of 8, and we will have 8 choose 0 there as well. So then the gap here. So I'm going to squeeze 8 through 1 here, and q is multiplied with x, so that was raised to the power 1, 1 to any power, it doesn't matter. And here coefficient of x will be, don't forget the q goes with x inside the bracket, so that's x cubed and so on. So I'm gonna write it neatly because that's not a very, I didn't intend to write the answer there. So when you write the first 3 times, you end up with this expression. Okay, so 8 choose 1 is 8, 8 choose 2 is 8 times 7 divided by 2 is 28. So that's 28. And here, don't forget q is squared, x is squared, and so on. So that's 28 here, and that's 8 lots of qx, and we got a 1 at the front. So that's answering part A. We answered part A of the problem. Does have more than one part. So now we've been told in the next part of the question is that uh, given that the expansion of blah blah 1 plus qx to the power 8, the coefficient of x is minus r, and coefficient of x squared is 7r. So what we are saying is this coefficient here, 28 q squared, is 7r. We can divide both sides by 7, so r is 4q squared. And we've been told that coefficient of x, that's 8q, we'll write it here, 8q is minus r. So we need to find the value of q and r. So we have two equations and two unknowns. That's fine. So this r is opposite of this r because it's got a minus sign. So we could say that r equals to negative 8q. So now we can equate them to each other. That r is negative 8q. And so we can just equate the very left to the very right and say 4q equals to negative 8q. We can factorize and divide by q. So if we divide by q, we know q is not going to be 0. It's not going to be 0 because otherwise our binomial expansion would be pointless. So we are allowed to divide by q. So we're going to get 4q equals to minus 8 and divide by 4, and we will get a negative 2. So q is minus 2. You go back here and you substitute q equal to minus 2 in this expression here. Minus 8 times minus 2 equals to 16, and that's the value of r. Does it make sense for it? Yes, of course. Alright, so that's my working out. Yes, r is 16, and this is another way of going through the same problem. I had it written by hand here as well. So in the end, you end up with q is minus 2 and r is not 0, r has to be 16. Okay, I hope you found this helpful. I'll see you in the next video.